Okay, on the test, they drew a titration curve. That's why I made it extra credit, because some of you have never done a titration. All right, they started up here at 0 amount added, and they started at 14. Therefore, what was it that you started with, an acid or a base?
A base.
You started with a base, but the question said what was being added. Okay, so you were adding an acid to neutralize a base. Does that make sense?
Mm-hmm.
Okay.
Wait,
Now,
the second one was at 50 or 7?
where is it the equivalence point? Where have you become neutral?
But
Is
it's
at pH 7.
what
What volume was added? 50. All right. Yay. Okay. Now, so let's look at titration. We're going to look at really in-depth at titration for a couple of minutes, and then we're going to talk briefly about buffers, and we'll hit that more on another day. All right, titration. The idea is this. Ready? In the real world, you're going to be working, if you work in chemistry, one of the things you'll be doing is you'll be working in some factory somewhere. Let's say we work in a vinegar factory. Okay? Now, here's the deal. If you sell vinegar that's too acidic, people are going to be very upset. If you sell vinegar that isn't acidic enough, people are going to be upset. So what you have to do is you have to say, okay, the vinegar I've produced is the right pH. So what you're going to do is this. There's somebody who's in what's called QC, or quality control, that their job is, here's a vat of vinegar. We just made a vat of vinegar. Whew, say that 3 times fast. All right? So you made a vat of vinegar, and he goes out, he or she takes a sample of that vinegar. All right? They go back into the lab, and they titrate that vinegar. All right? So vinegar is a what? An acid or a base? It's an acid. It's acetic acid. All right? So they're going to add a base to it in order to figure out the concentration of the vinegar, of the acid in the vinegar. Does that make sense so far?
Yeah.
Okay. So here's the deal. What they're going to have is they're going to have what's called a standard. All right, they're going to have something that we know the concentration of the OHs inside of that solution. Okay? So, sorry?
That's what a standard is?
Yeah, the idea of the standards are that I have something I know the concentration of to a fairly high degree of accuracy. And now what I'm going to do is to add that to my vinegar, and I'm going to see when it gets neutralized. All right? And so what's going to happen if I were to follow it on a graph, this being volume OH added, and this being pH, the pH is going to start below 7 because it's an acid, and it's going to slowly go up. And then at some point, it's going to shoot way up. All right? And then what's going to happen is it will again start to level off. Now, those of you that already did titration, you know this, because if you were probably using phenolphthalein, which was colorless, and you were pouring in little bits of base, and then all of a sudden it would go colorless, you'd add a tiny bit and it would turn bright pink. Okay, how many of you did titrations before? Okay, I'm going to talk to first-year chem teachers. I want to get you guys doing titrations. That would be a huge help to me. All right, so you add acid, you're adding base, gradually the pH is going up, then all of a sudden the pH shoots way up. All right, now for the purposes of our quality control person, they just want to know this point right here. That's the only thing they care about. All right? Because when it hits right around pH 7, give or take, and we'll talk why give or take here in a minute, but when it hits pH 7, what do you know basically has happened? What do you have the same amount of? It's neutralized, right? The amount of acid is equal to the amount of base. Now, we've said before when we were doing, let me not confuse the issue. Okay, so we know that the moles of acid, vinegar, are equal to the moles of the base. You agree with that?
Yeah.
Okay. Therefore, the molarity of the acid times the volume of the acid equals the molarity of the base times the volume of the base. Is everybody okay with that? No magic there. That's just derived from the idea that molarity equals moles per volume. Therefore, volume molarity equals moles. Right?
Yeah.
Okay. Now, what do we know in our hypothetical here? We know the volume of hydroxide added. We know the concentration of the hydroxide. And what's the third thing we know? Do we know the volume of vinegar? The volume that we took from the vat of vinegar. Okay? So we know if this side is the acid, we know this, we know that, we know that. Can we now find the molarity of the vinegar?
Yeah.
Okay. So, for the purposes of quality control, all we need to do is we need to figure out where it hits the neutralization point, where we've used up exactly all the acid so that it becomes, neutralized, and we can figure out exactly how much the concentration of the vinegar is. Hurts when that happens, doesn't it?
Yeah.
Trust me, too many times. And the thing is, they move and attack you when you're walking.
Yeah.
All right. Now, let's take it up another step further. Is everybody okay with this idea?
Yeah.
The absolute simplest titration is just this. Neutralize whatever it is so we can figure out the unknown of these four variables. All right? The way it works, just for those of you that have never seen it, you've got what's called a pipette, not a pipette. Burette, thank you, sorry, it's been a long day. All right, the burettes are metered from 0 down to 50, or whatever it is. You then take yourself an Erlenmeyer flask, you put whatever you're going to titrate into it, all right? You add some sort of indicator. Now, some of you looked at the indicator chart that was on that video. The idea of the indicator chart is nothing more than this. They show different indicators changing in different places, right? The idea is this particular indicator changes at a pH of 4, say. Okay? This particular indicator changes at a pH of 7. All right? So different indicators are useful for different purposes. For instance, if we're just trying to say it's neutralized, we want something that changes in the 6, 7, 8 range, so we'll probably use phenolphthalein. All right, that's the classic phenolphthalein. Weird spelling. All right, changes right around pH 7. Okay, so when you do simple titrations, you probably end up using that stuff. Is good?
It's good.
Is good. Okay, could you stop that for a second?